My name is Daniel Spicer. I'm the Chief Security Officer at Ivanti. Been at Ivanti a little close to 3.5 years. Prior to that, I worked in incident response though. And Jacob?
All right, and I am Jacob Thompson, and I've been working on the Flare team at Mandiant Google Cloud for just over 5 years. I concentrate on our offensive task force team, where I work on both malware analysis and the offensive side of security, including source code reviews.
Excellent. Thanks for joining our talk. We're actually going to talk about a different way of looking at secure by design. We want to talk about secure by design as it relates to software libraries and components in software, not just the packages we add to an operating system. And with that, I actually want to visit a vulnerability that is very familiar to us, which is Log4j. Log4j got our attention for a lot of different ways, for a lot of different things. It was a big first for the industry. But one of the things that really struck me as interesting when I was thinking about Log4j afterwards was how easy it was to actually get rid of the vulnerable code. There's an image here, a screenshot from the Google blog about how to just unpack the file and just take out the vulnerable code by deleting it. And most vendors, including Ivanti, did this in a lot of our software and recommended this to a lot of our customers without any impact. And that's kind of a crazy thing to think about, right? We've actually gone in and just stripped out a class file in Java, and there's no reason why the software would fall down or stop. That speaks to a broader problem about why is that functionality even there? And so that brings me to think about what are our secure by design principles, right? We talk about should products already be configured with best practices defaults. They should have attack surface reduction and be only enable in what you need in order for it to essentially run. And then of course, some other principles, especially around making it very easy to loosen the security requirements or add functionality as you need, rather than big lengthy guides on how to fix it. We talk about this a lot from operating systems. We talk about it from a product perspective in terms of products we sell. But my question is, what really is a product when you're starting to talk about open source? This is actually kind of a big and interesting problem that we need to consider. In a lot of cases, open source packages are not secure by default. They include the entire set of functionality, and not just the functionality of that particular open source package, but all of the other things that they import along the way, all the additional transitive dependencies that kind of follow along with it. And this isn't just an issue for open source, although that'll be the primary point of this discussion. You should also consider about that from an OEM in perspective. We work with a lot of different companies, and Ivanti especially. We pull in packages from other companies. We also package up our software and ship it off to other companies so that they can use our components, right? Are those secure by default? Does it only include the necessary minimum functionality in order for it to perform its core function, or do we have things enabled and turned on that aren't really necessary? So I want to dive into a use case here that is very important to Ivanti, which is the XML Security C library. This was is a fairly old library, has a lot of history and legacy. The purpose of this library was to implement exactly according to the RFC specification, the XML digital signature and encryption specification. It's primarily used for shibboleth. And until early in January, I think that most people thought that it was only used for shibboleth. But the challenge with this particular segment of code is it actually follows the exact RFC specification, which includes resolving any URIs and paths that are provided to it. And therefore, when you import this library, if you don't take additional checks and enable certain restrictions within the library, it will happily resolve those for you and call out to external websites or internal websites and ultimately actually introduced an SSRF into Shibboleth, which was fixed upstream. The fix was not put into XML Security C. By default, it resolves whatever URI you give to it. So we're going to open up here and talk about an Ivanti vulnerability from January. This is 21.893. And we also had an SSRF because when we went and decided to import the open source implementation of Shibboleth into our source code, we figured we already had the XML Security C library. Let's use it in other places that would be helpful. And the assumption here was that that library would be secure by default. Of course, this was a very different time when we introduced that library. Ivanti probably didn't even exist. This was still Pulse Secure days. But the idea is that we would need to configure something in order for that URI reach out to happen, and that's not the case. So we actually reached out to the maintainer with the support of Mandiant. I think that's pretty public now. There's a blog post about it, and asked the maintainer and asked the Apache Foundation to help us put out a CVE about this. And the answer was essentially no. They felt like nobody else should really be using the library, that they fixed it upstream in Shibboleth, and basically put up a banner just to warn people not to use the library. And now I think they have taken the library entirely offline instead of just deprecating it and moved it into the Shibboleth properly. That's probably how it should be done. But if anybody else ever grabs that code, they run into the same issue, right? We beg, borrow, and steal code as developers all the time. And this becomes an issue of, is this particular piece of code secure by default? I just want to quick shout out to the Mandiant team who actually reached out to other people who helped us identify who else was actually using this library, because it wasn't just Ivanti. Gave them a heads up, making sure they weren't going to be impacted by this. And also CISA actually helped us a lot in intervention with Apache and trying to get them to understand the seriousness of the issue. But as noted, the project's essentially retired. So we're in a position where software applications are not just the code that one company writes. It is a bunch of code that we import from open source, we take from OEM in, and the more complex our software gets, the more that we're in this challenge of supply chain, where it's not just convoluted from how do you secure the supply chain, it's also, is that supply chain secure at every step of the way, from the implementation and the use of that code. I think it's also worth noting that there's some interesting challenges about when do you actually say something is secure by default, right? A lot of our libraries we actually get from package managers. We pull those in, and we get something added to our code. All the transitive dependencies come with it, and then we freeze it, right? And that creates us issues in terms of vulnerabilities in those packages. It also creates an issue, and it's already pre-configured, right? Whatever that configuration is of whatever we got from the package manager already has that configuration that may or may not be secure by default. And then, of course, all the packages that you pulled along with it. In other cases, we'll see that you actually have to flip things off at compile time for a lot of libraries in order for them to not have certain features. And that is, if you're switching something off to get rid of functionality, get rid of attack surface, it's by default. It's not secure by default.
Okay, so we would like to talk about some other open source projects that also face this issue. So either they have not been secure by default in the past and has been fixed, or there is just inherent to the problem they're trying to solve that it is difficult to be secure by default in a way that can satisfy everyone. In terms of the security community saying, like, be very untrustworthy, turn everything possibly optional off by default, and so forth, as compared to a developer who is more concerned about compatibility, backward compatibility, and ease of use, and so forth. So we brainstormed as a team to try and come up with some more examples to illustrate these points. And one of them that we thought of 2 examples is JSON Web Tokens. So these, of course, are ubiquitous in web programming now. They probably have been for about 8 or 10 years or so. And of course, very quick overview, it's a set of key value pairs, right? In a particular syntax that is very similar to declaring an object literal in JavaScript. You don't necessarily have to be using JavaScript on either the client or the server to use these as a serialization format, but in practice, nowadays, of course, that's the most common case. So JSON Web Tokens are designed so that they can incorporate tamper resistance or an integrity check. You can put information in there that one component of your application produces, such as who is currently logged in, or what privilege level does the current logged in user have, and sign it or produce a message authentication code on the components of that JWT, so that other components in your web application or other systems that are trusting the information in this JWT know that it is authentic. Of course, things can unravel. So what signature algorithm you're using is embedded in the token itself. So common, perfectly valid algorithms would be, say, RSA 2048 or HMAC SHA-256. Unfortunately, the JSON de facto standard also allows for none for testing purposes. It wasn't long until that reached a production application, and of course, that's a disastrous result. That one's pretty easy to fix, because why would the default behavior ever be sensible to allow none? You should require like a -- debug or maybe an environment variable debug mode or something like that in order for none to even be allowed to execute without, say, throwing an exception or something. Another one that's slightly more complicated is that, remember I said that a JWT is a set of key value pairs. Well, what do you do about duplicate keys, right? And nobody necessarily thought thoroughly enough about that before these became popular to officially standardize what you do. So imagine you're a JSON library developer. You probably have some historical behavior. If you see duplicate fields, maybe you take every occurrence of that field and sort of implicitly create an array of everything that was provided to you and pass that to the application parsing the JWT. That would be a nice behavior in the sense that that is exactly how duplicate HTTP headers work. Maybe you had a different behavior. Do you allow the very last occurrence of a duplicate field to override everything seen previously, or perhaps you lock in the first occurrence and throw away the rest? In either case, you have a legacy of users of your JWT library who are counting on whatever behavior you chose. So perhaps in the future, you want your default behavior to be to reject JWTs that are either syntactically or semantically invalid, which they would be in this case. Well, now you have everyone who uses your library and upgrades gets upset if it turns out they were legitimately using these things in some way with duplicate fields. Different example. Here's another one that's sort of difficult to solve because things have evolved over so much time. So you're an application programmer. Given OpenSSL, it's most likely in either C or C++ or in some other language that has wrappers around those, like the Python OpenSSL library. Well, you are establishing a TLS connection to some server, and of course, the standard behavior is if there is a client certificate, you prove your identity to the server, but always the server proves its identity to you by providing a certificate and proving ownership of that certificate by possession of the private key that belongs to the host name for that server and chains to a trusted root. And of course, you have to satisfy both if you're actually being secure. Well, as the application developer and library developer, you have a confusing situation here. There are 3 different places where there's a host name involved. First, you are resolving a host name to an IP in order to make the connection to that server. OpenSSL may not even be involved at that point. So when it comes into the picture to, say, take that socket and begin the negotiation, that host name has already gone off somewhere and is not necessarily even available for OpenSSL to see. The second host name is of relatively recent origin, recent meaning after Windows XP, for example, which is support for virtual hosting on TLS. And if we think back before HTTPS Everywhere, it was just accepted. You didn't do virtual hosting on TLS. You either used a wildcard certificate or dedicated IPs. There was a TLS extension added called server name identification, and that's what step 1 on this list of correct operation does. You tell OpenSSL, when you connect to this server, give it this host name so that it knows which certificate to use on its end. That is completely separate from telling OpenSSL, I only trust certificates signed for this host name. That's what step 2 is. You have to do both. And if you don't do them, the default is some legacy behavior where it either trusts everything or is waiting for you to specify a callback function so that you handle the host name verification yourself. If you follow step 1 and 2 correctly, then everything works out. The server name identification tells the server what certificate to use, and OpenSSL is able to do both pieces of that validation, chaining to a trusted root and either the distinguished name or the subject alt names specify a host name that you wanted. So think about here, it's interesting if you're not secure. Say you forget to do step 1. Well, in any modern environment, you're immediately going to know you did something wrong because the server is going to say, like, I don't know what host name you want, or just give you the wrong site. Say you forget 2. No one notices until a security test is done. One option here is make better coding standards, make better hardening guides, but maybe a better one is use higher level libraries in this case. So if you use curl, you're giving it a URL and it can handle everything else and do security by default. So going back to a more philosophical level in terms of how did we get here? We were having this discussion as we came up with a presentation, and something I think is worth mentioning is Postel's law. So John Postel was the first editor of the RFCs. Back with, you see RFC 760, that's a very early one. Remember, I think SMTP is 822. It codified this philosophy undergoing that very early, like, hacker in the positive sense, internet of let's just get something working, and the fact it worked at all was pretty impressive. And they codified this idea or philosophy of if you are on the internet speaking some protocol, when you generate outgoing traffic, follow the specification strictly. When you're receiving incoming traffic, then be very forgiving, and then everything will be as compatible as possible, right? You always follow the pessimistic case when you produce these packets or frames or whatever, and you are forgiving when you receive input. So some of that is fairly harmless. A lot of the text-based protocols say in the RFC that line endings have to be, say, CRLF, but in practice, all the implementations take a plain LF also. So that's pretty harmless. But where this got us into trouble is following this not just in implementation and default configuration, but in practice. And I think the best example of that is the past decade of TLS vulnerabilities, particularly earlier in that decade, that all sort of leverage this behavior in some way, or this philosophy. The one I'm pointing to specifically is Drown, and that one used the mere fact that a server supported SSL 2.0 to leak information about the RSA private key that then, despite the whole philosophy of this law being that both sides will negotiate the best connection possible, well, now you can use this SSL 2.0 implementation to leak information that is security relevant that then you can attack on a better version of that connection that happens to use the same key. Because of course, no one would configure their server to say, oh, if you're SSL 3.0, I'll use this other certificate. If you're TLS 1.0, I'll use a better one. That wasn't happening in practice. The vulnerability I pointed out was Drown. There were other ones there, the Poodle one, for example, where export-grade cryptography. Why was that still in there in the 2010s? Well, because nobody thought to turn it off because of that philosophy. So what about something more positive? Well, I can switch to something, recent CVEs aside, that I think does a good balance of this. And that is OpenSSH. So they have this idea where they have iterative improvement to security. And they will make those changes in minor releases. That is a different philosophy from major breaking changes in a full release that only happens every several years. Or even worse, a rewrite or something that has a lot of growing pains, a lot of transition period that either succeeds, Python 3 coming to example, or doesn't succeed so much, Perl 6 or something like that. They make these improvements a little bit at a time in minor releases. So you're always getting a little bit better. You're not dealing with being an entire world separate from the current version when you finally decide to upgrade. They will make advance notice and they will phase in these changes. So if you read the OpenSSH release notes, they're nice and concise for one, they're accurate and technically oriented. They will say in 6 months, we're thinking about no longer supporting SHA-1 in this context, or we're thinking about disabling the command line by default, which is something they actually did. Then, maybe 6 months to a year later, they will disable that option by default at runtime. So I actually know someone who's a chemistry professor and has been for a long time, but uses Unix and Linux. They ran into this because they had a SSH key pair they generated in like 1998 that was 768-bit RSA. And finally, they updated some version, either on the client or server, I don't remember which. It started complaining about it, led that person to post on the mailing list that we have for Linux issues saying, what's going on here? And then everybody, of course, was like, what are you doing? And I think looked at the timestamp on the file or something. They will allow you to revert to the previous behavior at runtime. That could be for like just a year or so if it's something that really bad, or I think some of the group 1 Diffie-Hellman host key stuff is still in there disabled by default, but you can turn it back on for old servers. Finally, after that has happened, only then do they remove it at compile time. And they actually do remove it at compile time. That gets rid of the maintenance burden that I think helps with all this even much more. And also gets rid of the code itself so that if it can somehow be leveraged, even though it's disabled, that's no longer a possibility. Another thing I think is important here, they don't have a philosophy of like every default setting has to stay the way it's always been. They don't write some 500-page hardening guide saying, oh, by the way, RSA 1024 isn't a good idea, CBC mode ciphers aren't a good idea, this could be a side channel, you probably should disable it, and so forth. They will actually go in and change the default behavior, and the sysadmin has to revert the old behavior if they want to, and if the project has determined that should even be allowed. So they're not afraid to remove things either. So to start to summarize this message here, what should you do trying to understand your own supply chain, either in writing this software or as the customer who has to use it? Well, one of them that we already mentioned with the XML security C thing is transitive dependencies. So that specific example was, I'm writing an enterprise software product, I use library A. Library A depends on library B, so I can also use B. Well, it turned out that if the direct dependency was doing a workaround for a security hole in that transitive dependency that you don't know about, that's exactly what happened. Another thing about transitive dependencies that we've also dealt with some pain with is multiple copies of transitive dependencies brought in by different direct dependencies, and trying to audit and generate an SBOM. They appear to be duplicate. Are they really duplicate? Is one of them a long-term support version with backported packages that you've got to dig into to find that out, while the other one is not? Did you patch one and think you're done and there's actually a duplicate copy elsewhere that's still vulnerable? Another one is that a lot of these very package manager intense scripting languages will sort of deal with these rapid release cycles by allowing you to build your requirements file and lock to a particular version of a package so that you're not constantly testing for compatibility. Well, if that package manager allows you to check for CVEs against your locked version file, obviously that's a great idea and something you should be doing as part of your release cycle. Something that was definitely an issue with the XML Security C, if you're using a project and it's sort of dying off at the maintainer, but you don't realize that, you could get into this situation where it hasn't been fixed, not because people aren't knowledgeable or suspicious about this vulnerability, but because no one is, I don't know whether you want to call it passion or like actively involved in that project enough to be keeping up on releases and fixing vulnerabilities. And finally, this is something, if you're using an open source project, if it's a big one that's, say, backed by Red Hat or something, that's great. But if it's a small one, maybe they could really use the help keeping up with CVEs, and maybe you could even help with testing or informing them that you're even using certain functionality so they know it's important. Something that we kind of reflected there, if an open source project is fairly inactive, that could be because it's essentially complete, like something zlib. Or it could be that maybe the world has kind of moved on to a different way of doing that protocol and so forth, and it's just become legacy, and that's an important thing to be tracking in your open source dependencies.
So one of the unique things about being a CISO or a security officer within a software company is you kind of get to do it on both sides, right? We have customers who come in and ask us for how do we assess our supply chain. We also obviously have vendors that we use, and we need to go back to them. And so with that kind of unique view, I want to share back to you guys some of the things that we now do and really try to enforce against our supply chain. And I'll actually start on that last one. I'll just want to reinforce that. We actually push our vendors very hard to give us a date in which they will contribute back to open source if a vulnerability of a particular version or branch isn't getting patched. It's a real stickler for me as a big fan of open source. If you're just consuming open source and you're not giving back to it, that's a real problem. So that's something that, and I'll be honest, I've been surprised about some of the pushback from bigger companies, not smaller companies on that one. But also, talking about transitive dependencies, just make sure the SBOM is complete when you're asking for it from your vendors. Make sure you ask specifically, are you including transitive dependencies? I think that also kind of goes into how do you handle the contribution to open source, and how do you handle locked packages? I think that all kind of feeds in, and you can squeeze one or two questions in a security questionnaire and you get quite a bit of detail.
What do you mean by transitive dependency?
Sure.
So you use something that's written in Java, for example, and they give you a bunch of jar files, and inside them are a bunch of things they pulled in with Maven that you don't consider you don't consider libraries that you use, but that brings in, and nonetheless, you could be affected by vulnerabilities in those packages.
It's actually very common when you're using open source components, especially those who have complex package managers, Python and JavaScript through NPM, that when you are importing some component in Angular, you're not just importing that component, you're probably pulling in 3 or 4 other packages along with it. And having a complete view of all of that is important to actually understand your entire risk surface of whatever that application is. And if you're a company trying to assess your supply chain as it relates to a vendor, you got to make sure that you're viewing all of that. You'd be surprised how many vendors just didn't know Log4j was in their ecosystem. In a lot of cases, that was actually a transitive dependency. It wasn't that they specifically were using log4j for logging. They used a component that used log4j for logging error messages, for example. Clarity on patching SLAs. I think it's really important. A lot of vendors are, unfortunately, a little less honest here in my experience in trying to ask them questions about what they consider to be within SLA for vulnerability patching. It is not just vulnerabilities in your code. It's vulnerabilities in the supply chain of different packages that you're pulling in. So make sure you understand if there's a difference between the SLA of what they're going to fix within their code versus third party. I think this really came to light for Log4j, but I think there's a few other cases where we have seen issues, especially in JavaScript, where companies, they were taking a lot longer to fix issues that were inherent in their supply chain rather than the code they actually wrote. And then the last note is just make sure you understand your vendor's view of hard forks. We talked a little bit about locked packages, and when you freeze the version of certain open source supply chain, hard forks means that there's an open source package, but I've imported the entire set of code, and I'm going to maintain it separately and myself in a different way. That causes a whole lot of really weird things in the SBOM. So for example, if you're using Log4j, but you've decided to hard fork it and make modifications and handle it yourself, and now you consider it part of your code base, right? Then you're not getting the security fixes necessarily from upstream, right? And you're not notifying your customers as part of your SBOM that you actually have a hard fork of an open source library. They can't assess that risk. So it's another question to just press on your vendors and your who are providing you software, and definitely last thing, don't forget to start asking SaaS vendors to give you SBOMs. It's high time that they contribute to that as well. They are just as much of a risk to your ecosystem as your on-premise. With that, we want to leave plenty of time for questions. So open to any questions the group has. All right.
I have examples in my life where we have vendor-provided code. We run, a source scanner against the libraries we're given. We find sub-libraries. You call them transitive here. I think about them as third-party or further down. They have vulnerabilities in them. We go back to the vendor and they say, yeah, well, that's an open source package. There's no patch for that. And by the way, we don't consider it to be a vulnerability because it's not used in our code. It's not executed. And then we're into this conundrum of, well, how do we prove that? We're stuck with a known vulnerability in a library. It's in our environment. The vendor's not working with us, and it's really a struggle, right? And we don't have the development teams to go and fix it ourselves. We can't do that ourselves. You have any ideas on how to handle that situation?
So when I was talking about this from a corporate perspective, as in I'm an enterprise customer consuming a product, we try to push that contractually, right? And that's why the question really comes to is, okay, so your SLAs is you patch criticals in 15 days. What criticals? Is it criticals in your code, or is it criticals in open source or third-party components that you're pulling in? And frankly, can you even do that, right? Is it actually technically feasible to do that? One of the other things we do is give a defined grace period of how long you can wait for an open source vulnerability to be patched, whether that's because of a specific version or because you are aware of that vulnerability, before we expect you to contribute back to that. And like I said, I'm not sure I'm going to name any vendors here, but there are some large vendors who their primary service is an open source software that they then sell as a professionalized version, and pushed back hard on contractually agreeing to fix open source within a set period of time, which is actually a little mind-boggling for us. As a developer, and Jacob, I don't know if you have different opinions on this, but for code that we write for Avanti, if we pull in packages, I push that same requirement back down to my developers, right? If you pull in open source code, that means at some level you've accepted responsibility for that, and that's why we do the risk assessments on open source packages. And we've added some additional controls based off of this event, specifically around those transitive dependencies. So third, fourth, fifth, sixth party, whatever it is, right? Making sure that those are all included as part of the risk assessment. Now, I don't know if you had other ideas on that one.
Right. I was just going to add about stable branches and some language communities that are kind of averse to that concept. And
Yeah.
then that could make you at a bigger risk than otherwise.
Yeah.
Yeah.
Hopefully that helps. Any other questions? Anything else?
On the point about it's in there, but we don't use it, I was thinking about gadgets for both ROP and these deserialization vulnerabilities could be an interesting rebuttal to that.
Sounds like future talk.
Right. Yeah. Like it's in your class path or it's linked into the binary and it's there but not used. Does that in itself increase attack surface? I would say yes.
And thank you everyone for your time. We appreciate it.